Hello, everyone. I think I said a similar thing last year at CryptIst because Mustafa and the team decided to put me last in the schedule as well last year. They kept the worst for last, but I'll try my best to not disappoint. So my name is Toghrul. I officially do research at Scroll, but you can mostly find me complaining about things on Twitter. So why Scroll? There are many L2s, there are many ZK-EVM L2s, so what makes Scroll special? So first of all, let's define what Scroll actually is. Scroll is an EVM compatible, terms and conditions apply, ZK-EVM based zero-knowledge rollup, terms and conditions apply, deployed on the Ethereum mainnet. Woohoo, we just deployed a few weeks ago. So now let's break. Finally, it's been too long. So yeah, I just said a bunch of gibberish, so let's break it down first. So let's dissect. So first, let's address the elephant in the room. What were those terms and conditions? So let's start with the EVM compatible part. So Scroll is EVM compatible. Why did I say that terms and conditions apply? Well, Scroll is almost EVM equivalent, and I'll explain what that is EVM equivalency requires equivalency, makes sense, with the EVM bytecode, which means that if you copy the code that was deployed, the smart contract that was deployed on Ethereum and deployed on Scroll, it should work out of the box. We're almost there, but we still don't support a few things that will make us EVM equivalent. That's why we say that we're EVM compatible. So currently, we don't support 3 precompiles. So precompiles are essentially smart contracts that was deployed natively on Ethereum to allow you to efficiently process certain functions. Mostly it has to do with cryptography, but there are also a few others. So one is SHA-256, which is a hash function. One is a RIPE MD160, which is a hash function used in Bitcoin. And one is BLEG2F, which is another hash function. So we're missing 3 hash functions. Well, curiously, they've only been called, I think, 1,500 times in the entire history of Ethereum. And they're not really used that much. So most of the developers will never need them, but we're still gonna add the support to them. And then we also don't support 2 opcodes. One is base fee, which is going to be added soon, which is the opcode that was introduced with the 1559 upgrade, EIP 1559, which was basically an upgrade to the economic model of Ethereum that required a new opcode. And then the second one is self-destruct, which is an opcode that allows you to delete the storage of the contract if you want to destroy your contract for one reason or another. Well, funnily enough, Ethereum is going to be deprecated soon anyway, so it doesn't really matter for us. And so technically, Ethereum equivalency doesn't really require supporting self-destruct as long as we support all the other things. So great news, we're going to be EVM equivalent very soon. I'm not going to commit to certain dates. Yeah, here knows better, but I'm not going to throw him under the bus because he's going to kill me later. So let's go to the next part. So Scroll is a ZK-EVM based zero-knowledge rollup. What does ZK-EVM based means? So you might have seen this article by Vitalik. He published it more than a year ago now. It was after EFCC 2022 in Paris, where there was a whole can of worms that was opened where how do you classify ZK-EVM, who's a true ZK-EVM, etc., who's the first ZK-EVM. I was involved in it, but don't tell anyone. And so once we become EVM equivalent, Scroll will be classified as type 2 ZK-EVM. We're currently type 3 ZK-EVM, so what that means is we support almost all the bytecode, so all the opcodes and almost all the precompiles, but we don't support all of them. That would make us ZK-EVM type 2.5. And type 2 means that you're also compatible with the gas schedule of Ethereum. So let's say every code by opcode in Ethereum has a certain cost. So let's say SS store by default costs 20,000, etc., etc. And we replicate that schedule. So basically, as soon as we move to 2.5, we'll automatically move to 2 because we already support the gas schedule. So as soon as those opcodes are added, we're just becoming a type 2. So as I described before, type 2 just means that we're both bytecode equivalent and gas schedule equivalent. And then the last part, which is the most, I guess, controversial. Scroll is a zero-knowledge rollup. And again, terms and conditions apply, blah, blah, blah. So according to L2Beat, we're a stage 0 rollup. Oh, what is stage 0? So it was started here because a lot of people were complaining, oh, you have multi-sigs, et cetera. You're not a real rollup if you don't have fraud proofs, etc. So Vitalik came up with this classification that allowed us to classify rollups based on how many training wheels they have. And what that means is like how many additional precautions that they take that don't make them permissionless or don't make them compatible with like this, I don't even know how to say it, I guess to the specification of a rollup. And then recently L2Beat introduced an updated version of it, which like eliminated certain sticking points that were debated a lot. And this is, so they have three stages, stage 0, stage 1, stage 2. Stage 2 means that you essentially have similar security to Ethereum and you're trust minimized. Stage 1 means that you still take certain precautions, but it's much less obvious than in stage 0, which has multi-sig, instant upgradability, etc. So currently we're at stage 0. But good news, we're working on becoming stage 1 and stage 2. Again, I'm not going to commit to dates because probably all of you know that giving promises about release dates in crypto always doesn't work out, and you end up with a lot of people unhappy with you. So I'm just going to say we're working on it. And so now back to the question. We went through all the terms and conditions, etc. Why Scroll? So let's go back. So Scroll was founded on the idea of maximizing compatibility with Ethereum without sacrificing efficiency. So what that means is we wanted to make sure that we are compatible with as much of Ethereum as possible without making proving blocks like extremely expensive. So let's say if you're completely compatible with Ethereum and you can support it fully, but then your proving time is 48 hours and it costs $2 million to make a proof for a block, then what's the point? Like, there's no point. So we took a bit of a pragmatic approach. We realized that certain things can't be currently supported. They can be supported later on. We can always migrate and become type 1 later. But certain things cannot be supported viably at the moment, and we made certain trade-offs. So additionally, we've been open source since day one. Most of our repos are open source and have been open source since day one. There are a couple that are still not fully open source, but so for example, the bridge was just recently open source before they made that launch, and that was primarily because we had a really, really outdated version of the bridge, and we were we reworked it quite a bit, and we decided to not open source it until it was audited in case somebody else decided to bridge it, and then to fork it, and then they realized that, oh, actually, it's completely broken, and you got drained. Congrats. So yeah, we didn't do that. And then on top of that, our ZKVM is a bit of a community effort. So it started as a collaboration between Ethereum Foundation's privacy scaling explorations team and Scroll, and also some various other contributors. So it was never been a fully internal effort. So we welcomed people contributing, external people contributing. And we feel like that's a best way to go about things, because then you have more eyes on the project, on the code, and the more eyes you have on the code, the less likely you have to less likely it is that you end up having critical bugs. And therefore, it just made sense for us to have as many people working with us and sharing their ideas and helping us make sure, not only us, but the entire community make sure that this ZKVM is built in as of an open manner as possible. And we also prioritize compatibility with existing tools and code. So most of the tools that were built for Ethereum are compatible with Scroll out of the box. You don't have to download new modified tools or like recompile code or anything like that. You just basically use whatever you have been used to using on Ethereum, and it should work out of the box. There are certain small edge cases, but for 99.99999% of people, it doesn't really matter. So another thing that is important, and what I mentioned earlier, is we try to maximize compatibility with Ethereum. We're also try to maximize compatibility with the existing code that Ethereum has written. So for example, our execution client, so our sequencer implementation, is a slightly modified version of Geth, Go Ethereum, which is the primary execution client that Ethereum uses. There are certain things that we changed, as I mentioned earlier, to make sure that we are as efficient as possible, but it's not that different. And we're compatible with a slightly modified version execution trace of Ethereum, which means that we can theoretically be compatible with any other execution client. So think Nethermind, Reth, etc., Aragon, etc. And we're actually gonna have some news about it soon, so be on the lookout. And we also spend a lot of time focusing on how we can maximize this protocol security, because you can build the most resilient proof system, you can build a multi-client setup, but if your proof system is insecure or your validating bridge has a bug, then it doesn't really make sense. You're still gonna get hacked and everything is gonna be stolen. So we have been in a testnet phase for 1.5 years. We had 3 iterations of the testnet. First one was a bit of a closed one. We were the only ones who were able to deploy contract, but users were able to use it. So we were able to use the load on the to test the load of the sequencer, etc., etc. Then we deployed fully permissionless from the smart contract deployment perspective version on Goerli, and then at some point we realized that Goerli is being deprecated, so it doesn't really matter. It doesn't really make sense for us to use it anymore. So we deployed on Sepolia, and a bit of an upgraded version, and that's where we are now. So in total, we spent more than 1.5 years testing our protocol. And we've also spent quite a lot of time working on multi-provers, which means that instead of having one proof system that attests to the state transition validity, we have multiple proof systems that work in parallel. And basically, if one of them disagrees with another, then the validating bridge stops working, and then you can either use governance or a security council to dispute and pick the one that the majority believes is actually saying the truth. In our case, we worked with a team of leading SGX experts to implement a SGX-based multi-prover. And in this case, I know SGX has a bad reputation and people think, oh yeah, SGX bad, whatever. But in this case, it doesn't really matter because it's just additive. The security here is additive because we don't rely on SGX for correctness, because we still need our Halo 2 proof system to work. So if SGX is broken, nothing gets stolen. The worst thing that can happen is there's a temporary liveness failure. But if Halo 2 gets broken, which in an original case would have meant that all the funds are gone, in this case, it just means that, again, there's a liveness failure, and then we just need to fix Halo 2, which means that anyway, we end up with a better situation where a potential correctness failure is now converted into a liveness failure. And it's going to be deployed on our testnet soon. Again, not saying when, just soon for now. And then once it passes some testing on the testnet, it should hopefully be migrated to the mainnet. And then we've also been researching the potential use of multi-verifiers to combat validating bridge bugs. And what that means is you can use multiple different implementations of the validating bridge to ensure that the state mutations have been correctly recorded. So for example, you can implement a bridge in Solidity, and then another bridge specification can be implemented in Viper. And then you have a very, very small middle layer in between that basically checks that both of them have written the correct, the equivalent stuff to the storage, which means that if this works as intended, it's almost impossible that a bug can result in the funds being stolen, because you would essentially have to have two identical bugs in both implementations for this to be exploited, which again, this will allow us to convert a potential correctness failure, which can result in funds being stolen, to a liveness failure, which is an acceptable trade-off in our opinion. This is more of a research thing, so it's not going to come soon, but hopefully it's going to be on the testnet and mainnet at some point in the future. And then we are also working on decentralization a lot. We spent almost the last 2 years thinking about how we can decentralize, and we went through so many working models that I can't even I'll fail to count how many we went through. But yeah, but I think we're at a point now where we're almost ready to present a more concrete version that we think would be the right way going forward. We still would love to interact with the community and get community input, because having multiple people from different teams and just community members in general looking at things just makes things better, because you have more eyes on it. And so we should be publishing quite a lot of information on our decentralization research soon. We've been mostly keeping quiet about it, but I feel like it's time for us to be a bit more public. I'll actually be talking about our approaches a bit concretely later in the week at a couple of different events. But yeah, so if you follow me on Twitter, you can catch my tweets about where I'm gonna be, so you can come and listen. You're more than welcome to. So yeah, I will reveal more details about it soon. And then a small spoiler, I actually forgot what the spoiler was, I'll be honest. Oh, yeah, right. Yeah, now I remember. Yeah, we will have no sequencers most likely, because we realized at some point that sequencers just act as middlemen between builders and provers in a setup which has both decentralized sequencers and provers. And so it's most likely that we're not going to use sequencers and just outsource building to external builders and then use provers to actually sequence and run the consensus. But again, as I said before, there'll be more updates later on. So in general, you can think of Scroll, the purpose of Scroll from the perspective of an Ethereum developer is this: copy, paste, deploy. That's it. That's how it should work. Thank you. And if you have any questions, feel free to ask.